Hello and welcome to Integers and Absolute Value. If you are a regular class student, you have pages 191 through 194, and this lesson will go directly along with that from your book. Or you can use the study guide that I gave you. I printed that out for the enriched class, and there are extra copies on Google Classroom. So here we go. On page 191, we are asking, what is an integer? So they put integer into the middle of this graphic organizer for you. I typed on here, an integer is whole numbers and their opposites. Numbers on the number line, they are rational. Now we'll get into exactly what a rational number is at another point, but I wanted to throw that out there while we were talking about the definition of an integer. So numbers like 5, -8, they're integers. They're the numbers on the number line. It's any number in this set, -4, -3, -2, -1, 0, 1, 2, 3, 4, and it continues on both ends, so it goes without end. So whole numbers, 0 through infinity, and their opposites, the negative numbers. So describe it, I like to say, on number line. Okay. Picture it. They drew a picture of a number line there so you can see those. Examples. Oh, pick your favorite numbers. 1, 5, -3, 0. All right. List some non-examples. So like a fraction, a decimal. We could even say a negative decimal would be non-examples. All right, at the bottom of page 191 is the real world link. The bottom of a snowboarding half pipe is 5 meters below the top. Circle the integer you would use to represent this position. So if it's below, we would say down 5, -5. Okay, negative numbers are also used in temperature. We could use it in a depth, how far somebody goes down into the water. That really is a D. Really need to use my stylus on the next video. Okay, so negative numbers can be really useful in describing positions and amount. All right, so negative numbers are on the left side of 0. They're less than 0. Positive numbers are on the positive side, on the right side of 0 on the number line. 0 is not negative or positive. It's just in the middle and neutral. All of them are whole numbers. All right, integers can be graphed on a number line. To graph an integer on the number line, draw a dot on the line at its location. So I know you've probably done this before. I just wanted to make sure that we were clear. It's a graph. You put the dot on the number line. Okay, next slide. Write an integer for each situation. An average temperature of 5 degrees below normal. So that's why they use the -5. An average rainfall of 5 inches above normal. So it's +5, +5. Plus is not necessary. So write an integer for each situation. So I'll let you pause me, give that a try, and then come back and check. All right, I'm giving away the answers. 6 degrees above normal. So if you're stuck on using that plus, it should be a +6. 2 inches below normal, -2. So this summer we had such a drought. Well, I'm sure we were at least -2 inches on our average rainfall. All right, graph the set of integers. Hopefully this is pretty simple. You can see that they have a dot at the -6, a dot at the 4, and a dot at the 0. Sorry, I didn't do those in the right order. So if we were going to graph them ourselves, and you can go ahead and do that yourself and check your answers if you want to pause. I'm going to put a dot at -2, a dot at 8, and a dot at -7. I'll do set D with a dot at -4, a dot at -3, tight. Oh, sorry, missed 10, dot at 10, and a dot at 7. So put a dot on the line where they are, and you can see I got them all on the same line. It's no big deal. All right. On page 193 to 194, they start talking about absolute value. Maybe sounds a little intimidating, but absolute value is really not a huge deal. How far is the number away from 0 on the number line? So you can see that -5 is 5 spaces away from 0. So the absolute value is 5. +5 is also 5 spaces away from 0. So its absolute value is 5. So when we write an absolute value, that's always going to be a positive number. It is possible to put a negative sign outside of those absolute value signs. We'll talk about that at another point. So on the number line in the key concept box, notice that -5 and 5 are each 5 units from 0, even though they are on the opposite sides of 0. Numbers that are the same distance from 0 on a number line have the same absolute value. All right, so every year, so my favorite example, and hopefully I didn't get caught off too much, is using a sorry board. And so lucky you, I've actually recorded myself using a sorry board. Jeff helped, and see if you can find my ghost of a cat in the background. Here you go. For this next one, they're asking you to find the absolute value of -5, the absolute value of 2, and then we subtract. So notice over here, this note about the order of operations. Absolute value bars, those lines on both sides of the number, are part of grouping symbols. So that's going to fall in place with parentheses. We want to make sure that we do those first and then solve the problem. So that's how we end up with 5 minus 2. So the answer is 3. Okay? So go ahead and try those got it's there. See if you know what you're doing. And pause. Okay, I'm going to give away the answers. So the absolute value of 8 is 8. For letter F, we have 2 plus the absolute value of -3 is 3. So our total is 5. And then for letter G, the absolute value of -6 is 6. We're subtracting 5. So 6 minus 5 is 1 for our final answers. So 8, 3, and 1. All right. So last example on the last page there, the last part of your study guide for this video. Nick climbs 30 feet up a rock wall and then climbs 22 feet down to a landing area. The number of feet Nick climbs can be represented using the expression the absolute value of 30 plus the absolute value of -22. How many feet does Nick climb? So if you've ever tried to climb a wall, you know that Nick deserves all of the credit for completing every piece of climbing that he does. He went up, he came back down a little bit, but we want to know the distance that he climbed overall. So that's why it's 30 here, it's down 22, but we're going to consider that that distance a positive number after we find that absolute value. So 30 plus 22 equals a total of 52 feet that he climbed. All right, so hopefully that all makes sense. We'll be checking in on this later, and now that I think of it, I want to have a reflection on my website, so my classroom, so make sure that you fill that out too. All right, so here is my example of using a sorry board for absolute value. So here's my piece. I just drew a 4, and if you remember from playing the game of sorry, can I get this on camera? Well, you can kind of read it upside down. Oh, thank you, Jeff. There we go. All right. The card says, must move one man backwards 4 squares. 4 squares backwards? All right, so if I do 4 squares backwards, can you back it up there, Jeff, so they can see my move? Oh boy. Is it moving? Are they going to get seasick?
No.
Okay. 1, 2, 3, 4. Now, if I moved backwards 4, that would be like a negative number. But did I count -4? Did I say -1, -2, -3, -4? No, I just counted to 4. So that's my example of absolute value.